always thought to be the first speaker, so let's give a big round of applause when she comes out. All right? So our first speaker, her original career goal was to play first base for the Red Sox. So everyone can say, "Go Yankees," when she comes out here, all right? Everyone, please welcome Megan.
All right, amazing. So, thank you. We figured it out. Okay, so my name's Megan Robertson. I'm really excited to be here kicking off the MYR conference. Some sad news if you're on the edge of your seat, ready to learn about R. My talk's actually just about data science in general, so you're gonna have to wait for some of our later amazing speakers. And I wanted to start off by explaining why did I call this Not Your College Stats course. So I've worked in data science for about 7 years in different parts of industry, most recently at Nike. And one thing I've noticed through working with a variety of teams, from marketing to engineering to product, that when I would explain to my colleagues what I do for work, bunch of math and statistics and computer coding, you can get like a really visceral reaction of, oh my God, I almost failed my college course. I had to take it 3 times. I just memorized a bunch of math. And today I'm gonna be talking about how can we use our data science models, help our stakeholders understand them, albeit at a very high level, and really engage them with our work through understanding that. So I say not your college stats course because I don't want to get those visceral reactions. I want stakeholders to really be able to understand how does data science work, how does it apply to their own work. So quickly, where we're gonna go in the next 19-ish minutes or so. First, let's talk about why we should even care about this working in industry. Then we'll move on to what are some of the challenges to keep in mind while we're doing this. And then lastly, how are we actually going to engage our stakeholders? And I just want to call out specifically, I'm going to be speaking to how do we get them to understand how our models work. Obviously, there's a lot going on in terms of making a presentation for our stakeholders. I've only got 20 minutes today, so we're explicitly focusing on how can we get them to understand how our models work, and then thus buy into more of the analysis and recommendations that we're giving. So first of all, why do we even care? I'm a data scientist. I spent many years in school doing math, learning statistics. I get paid to write the code. I get paid to make the models. Why do I care if my stakeholders understand them? My first point, data science is not magic. So I've worked with a senior leader who was not a data scientist, would go into meetings with stakeholders, and he would say, hey, I know you want to predict customer churn, for example. Our data science team, they'll wave their magic wand. They can get that done in 4 weeks, and we're all in the back of the room looking at each other like, okay, that's news to us. And obviously, data science is not magic, and when your stakeholders really understand what it takes to do what you do, you're gonna have a much smoother collaboration. You don't have to miss deadlines, have some of those hard conversations. So that's really important. And then, as stakeholders understand what you're doing, you're gonna develop stronger relationships. They'll understand what resources you need, what your timeline typically works with, and you're gonna have better collaborations moving on. This is not without its challenges. So in my career, these are the 2 biggest things that I've noticed that can be challenging when you're trying to get stakeholders to understand how data science works. So first one, fear or apprehension. I think this has grown, especially in the past 2 years, as things like ChatGPT have become more mainstream. There's a fear out there, my job's gonna get automated away, ChatGPT is gonna take over the world, we're all gonna be slaves to the robots in a few decades. And this is a real fear, because if people are worried about their jobs, that's their livelihood at stake, and you might face some resistance to them learning about data science and collaborating with you. So one thing I always keep in mind, especially when I'm working with newer teams, is to think about where does their unique knowledge fit into their analysis? Making sure they understand that they're still going to be part of the process, whether that's input into how the data is used, or that they need to do some unique part of their job with your analysis. And I'll talk a little bit more about this later. Another challenge, information overload. So if you're doing especially more complicated machine learning analyses, You spend a lot of time in school, right? Studying, learning all the math, doing all of that. So how can I condense, if I learned a model over the course of a semester, how can I condense that down into a short presentation for people who maybe haven't taken stats since high school? We don't want to go up there and have optimizations and all these symbols and calculus. The eyes will glaze over. So with that, you want to think about, how can you adjust the material based on your audience? Say I'm presenting to my marketing team. What I present to them is going to look incredibly different from what I would present to my software team, who's going to scale that model for me. So these are some things I'll talk about a little bit more when we get into how we do this. So hopefully I've convinced you that this is important, and if not, I've got the microphone for 15 more minutes, so you're stuck with me. And now we're going to go into just a simple two-step framework that I'll use when I'm thinking about a model I've built and I've got to present it to my team. And I'll use this framework for predictive models, unsupervised learning, any sort of data science analysis. And I'm going to start first with talking about some really general do's and don'ts that I've picked up over the years. So some do's that are really helpful to think about when you're building these presentations is first, relate it to a known concept. At the end of the day, a lot of what we do in data science is actually pretty simple ideas, right? If we think about something like k-means clustering, all k-means clustering does is use math to group together similar things. If I go to my stakeholders and I show them a bunch of cat pictures, we got orange, we got black and white, we got calico, and I say sort these into groups, they can do clustering. They're just not using the math under the hood that we use to do it at scale. So really think about that kind of big picture. What is a known concept that this is similar to? And also visual aids are really helpful. I'm going to go through an example use case and how I would present a data science model to some non-technical colleagues. And visual aids are really helpful to point through as you're talking about things. Don't hit them with a wall of text with a bunch of mathematical symbols. The eyes are going to glaze over. They're going to have flashbacks to that college stats course. A couple don'ts to keep in mind. Don't use overly complex language. It's easy when you're working with technical colleagues all the time. We've got our jargon, we've got our math terms, but I don't need to be in front of a marketing team saying, hey, we optimized this clustering algorithm to minimize the Gini index. This isn't Aladdin, get the genies out of here. We can just say, hey, we took our data, we used some math behind the scenes, and we've grouped together all of our most similar customers. Gets the same idea, they don't care what sort of measure I use to do it. And then lastly, don't be condescending. I'm not saying don't talk about your accomplishments. Obviously, it's important, take your bow when you deserve it, but you don't need to be out there in the room trying to convince everybody you're as smart as you think you are. Data science, especially when you're working with non-technical stakeholders, you want it to be accessible and engaging. So really be mindful of how you're presenting these topics. So now, let's introduce a use case. And I'm going to use this use case to go through the framework that I'll use, and then we'll end with how would I present an example model to some non-technical stakeholders so you can see it in action. So we're all going to pretend that we're data scientists for a professional basketball team. Amazing, super cool job. And we were tasked with building a model to predict shot outcome during a game. So if you're not familiar, basketball, that's the sport with the orange ball. We try to get it in the basket. You get points. You want more points than the other team. We can talk more about that at a break if you have questions. And if you're not familiar, the NBA has cameras in all of their arenas where they're taking pictures, multiple images each second of a game. With that data, we know where every single person on the court is as well as the ball. Ton of data, ton of stuff you can do with that. So we're going to pretend on the right here, we have all of this data at the time in a game when a shot is taken. We know things like how fast our shooter was moving, how close different people on the court are to them, how much time is left, what's the angle to a defender. Basically, using all of that location data because we're trying to understand what's affecting whether their shot's going to go in or not. Our coaching staff, they want this model because they want to have a better informed practice or games. Because if we build a model that says, hey, You know, obviously, if someone's right in my face, it's harder to take a shot. But maybe there are certain players who tend to not be set while they're shooting or something. So we can use this data to get a bit more information. So as the data scientists, we've made a random forest model that will predict the shot outcome. It's amazing. We're so smart. We're going to use it. Awesome. But we need to convince our coaching staff, hey, here's our analysis, here's why you should use it. So we want to give them a very high level understanding of where these predictions are coming from. So let's look at that first part of the framework. I have 2 steps that I'll always think about. And here we're trying to answer the question, how do we explain this model? So the first step I always think about is identify the key components. And here are a few questions that I'll use to answer that. So first, what are the main ideas of this analysis? When do you apply this technique? How would I label this model with keywords? And I'll often start with these questions, and I'll just write down everything that comes to mind, kind of a bit of a brain dump. And it can be helpful to think back to school of when did I first learn this? Because if you think about learning these things in school, like you'll start that big picture idea. Clustering, we're trying to group together similar things. And then you get into, well, how do we define it? What are we optimizing? What optimization function? All of that stuff. So I'll revisit my old textbooks, my old notes from school, or like intro to data science blogs. That can really help answer some of these questions. So for our random forest model, what might that initial brainstorm look like? So my main ideas, we're just combining multiple decision trees, right? We love decision trees, super powerful model. Let's see if we can use a bunch of them to make it even better. And when I'm making those trees, I'm just using the data to learn the rules, how I'm splitting them up, all of that sort of stuff. How are we applying it? We're just doing some predictive modeling, nothing too fancy. And then some keywords that come to mind with that model: prediction, ensemble, because we're bringing a bunch of them together, bagging, decision tree, variance, random sample. So once I've answered these questions, I can see what sort of patterns come between them. I see decision tree come up a lot, random, predictive, and I can start to kind of put together in my brain, okay, those are the main things that my stakeholders need to understand. The next question I'll think about, or step, is thinking about limitations. So what assumptions did I make, and what risks are there if I'm incorrectly applying this analysis? So this is obviously really important. As data scientists, we do have a responsibility ethically to make sure our analyses are being applied correctly. So I really need to emphasize to my stakeholders this situation. And what assumptions are we making? Our analysis is only as good as our data. So let's say our random forest model, we looked at every shot our team took last season. All right, that applies to our team only, and I'd say it's pretty representative. Maybe if we didn't make the playoffs last year and we're going this year, playoff pressure affects shot outcome, maybe something like that, but pretty representative. And then what risks are there if we incorrectly apply this analysis? So say we built a model specifically for our team, but then our coaching staff says, hey, let's use this to make a defensive strategy for an opposing team. Well, we didn't put any of their data into our model, so that defensive strategy might not make sense for another team. They have different skills, different players, all that sort of things. And thinking about the risks too, you know, we don't win a basketball game. I mean, depends on who you ask on the coaching staff, pretty low risk. But I just want to emphasize this point, because you could think about if you're building a model, for example, like clinical trial data, where your model is going to help influence what treatment patients are getting, that's a whole different type of risk. So really kind of sit down and think about it and make sure that that gravity of the situation is something that you're conveying to your stakeholders. So those are the 2 steps I'll go through, the different questions I'll answer. And now let's look through how would I actually present this random forest model to my coaching staff. So I just have 2 slides. That's it. And the first step, if you remember from what are the main ideas, we know random forest model is a bunch of decision trees. So let's think about first, how would I explain what a decision tree is? So you can see on this slide here, very simple visualization. This is a very simple version of a decision tree. And I'm going to relate it to known concepts. So, for example, in this room, how many people have used a flow chart at some point in your life to make a decision? A magazine, should I ask them out or not? You follow it out, you get an answer in a fun little pickup line. Most people know what a flow chart is, and at the end of the day, a decision tree is just a flow chart that we've figured out using math and a bunch of equations. So I would talk my coaching staff through saying, hey, let's imagine we're starting at the top here with a shot someone's taken during a game. They had 3 teammates within 10 feet of them, so we're going down to the right. Where did they shoot from? Inside the key. Our model is going to predict that they make it. So they can visually see, okay, this is how the data is being used to make that prediction. Again, this is a very simple example, because if we have dozens or 100 features, I'm not going to put all of that on a slide. That's very overwhelming. But they're getting the main idea of that, and then we'll say, okay, but in reality, we have, let's say, 50 of those features. We're putting all of them into this decision tree. What are some things that can change with this decision tree? The order that we're going through as we're following that flow chart. So that's something that we're using math to figure out, as well as how we're splitting up some of our numeric variables. So here we have 0 to 2 and 3 to 5. That's also done using math, so that at the end of the day, when we have our predictions, we have really similar outcomes grouped together as much as possible. That's what a decision tree is. I didn't have to talk about what we're minimizing, any of the math of it, and they can visually see that decision tree and say, okay, I'm starting to see where that comes from. Once we get that decision tree down, we can talk about combining trees. So a random forest, we're just making a bunch of decision trees. They understand this tree model because of our previous slide. So now we'll talk about, these are really powerful models, so if we combine a bunch of them together, we can get even more accurate predictions. But you might ask, hey, Megan, if we're using the same data in the same type of model, wouldn't we just get kind of the same tree all the time? And we'd say, why, yes, coaching staff, you're very astute today. Thank you for picking up on that. And this is where we can talk about what makes random forests different than just combining decision trees, right? So we'll say, well, each time we make a tree, we're only going to take a random selection of features of our data. Now, why does that make sense? So intuitively, with a game like basketball, if someone's in my face and I'm trying to shoot, or I have 3 people, that's going to be a harder shot, right? So something like my number of close defenders, that's going to be really influential in my model. But there are some other features that might not be, that are still affecting whether my shot goes in, but not as influential as those close defenders. So I'm going to say, if I can randomly select features, so I don't always get those close defenders in my model, some of those other variables, they'll be able to contribute as well. So the big idea there is we're randomly selecting features, so some that are still influential, but maybe not as influential overall, we can still see them. Great. And we're going to make a prediction, we'll look at what do the majority of our trees predict. And that's all I'm going to say about a random forest model for that level. Again, if it's my engineering team who's scaling it, great, they'll get more details, the nitty-gritty. But now my coaching staff can at least think about, okay, I know where this is coming from. Now how I can trust this analysis a little bit more, that'll really help with your working relationship. And I'll also emphasize, so here we just explained the model. We would then go on to talk about what features did we find were important, what were some patterns we found, and during that explanation, really emphasizing, hey, this is where I need you to work on LeBron James. Not that he needs any work to do in case he sees this presentation, but how can we go into practice with a plan for LeBron to work on X, Y, and Z based on what our model is saying? And that's where like, oh, okay, the data scientist doesn't know how to work with a superstar player. This is where my expertise comes in. So a few things I just wanted to mention in conclusion. One, data science analysis should not be a black box and should be accessible. This is especially important if you're not working in a research-heavy position. So like I said, for me, I've worked with everything from designers to marketing all over the place. And it's really important for you to have that relationship where you both understand what you're doing, because that's going to just help that collaboration. You're going to get a lot done. Second, presenting results is a balance between providing appropriate details and not overwhelming them. So my coaching staff, they got 2 slides. This is what a random forest model is. If they have more questions, great. Go into that detail if that's what they want. You'll also find some stakeholders who are more interested in more of that technical detail, which is amazing. But not everybody wants that. And then lastly, I'd say communication is an often overlooked skill when hiring and training data scientists. I've been in this field for 7 years now. I have so many students reach out to me, and this is the biggest thing I tell them. It's great, yes, you need to know how to code. You need to know the math. You need to know how to build the models. But at the end of the day, if you can't get other people on board, convince other non-data scientists why your analysis is important, it might just go in a drawer, even if it's the greatest thing ever. Really work on that communication. And with that, here's my email, my website. If anybody has any questions, feel free to find me. I'll be around the next 2 days, and thanks for having me.